Hello everybody. So what you're looking at here is the first slide from a video I made yesterday about producer and consumer surplus. And as I was going through that video, I said that I wasn't going to explain at that time what consumer surplus was or what producer surplus was and why those two things are calculated in the way that I have right here. Okay. Um, but right now I will tell you about all that. All right. So that was my intention when I made the video yesterday, that I would focus on just the math. And right now I'll tell you about all the concepts behind this. Okay. Now that story will begin with talking about something called the law of supply and demand curves, equilibrium prices. And then once we get all that done, I can lead up to telling you about consumer and producer surplus. Okay, so let's start with part one, just talking about what supply and demand are. So here I have some curves that are drawn, and well, how about this? Before I get too far ahead of myself, I am, as a disclaimer, I'm summarizing something that was, I don't know, probably, here's my economics textbook that I happen to have, and I'm summarizing like 20 to 30 pages of stuff in that book in this video, okay? So for everything that I say, there are more details that I could have added, but I want to make a video with just enough to explain what consumer and producer surplus are and why they're calculated in the way that I told you. Okay. So, all right, back on track. So part one, let's talk about supply and demand. So here I have some graphs, or as economists might call them, curves, that illustrate price versus quantity for some product. And let's not even try to think about what the product is. Use your imagination, all right? And there are points on it. And this is typically how we draw supply and demand curves. We put price on the vertical axis and we put the quantity that's bought or sold on the horizontal axis. Okay? And like any graph, there are points on it. And do you see this point right here on this demand curve? It says that the quantity is 40 when the price is 7. And then in your mind, you can interpret that like this. At a price of $7, consumers are willing and able to buy 40 units of whatever this product is. And what it is doesn't matter, okay, for the purpose of this discussion. All right, now you could say something similar about every single other point on this demand curve, okay? So just that's the concept. So you get it in your head that all these numbers have that meaning, okay? Now, the demand curve will have a certain shape. It might be a curve, it might be a line, maybe it's real steep, who knows, all right? But it will have a certain characteristic shape every time. And that is that it will fall to the right. The reason for that is because of this thing that economists call the law of demand. It says all else being equal, as the price of an item falls, the quantity demanded will rise, okay? And I hope that when I tell you that, you say, well, that's common sense. That's the way people are, right? Of course, as the price goes down, we buy generally more of whatever the thing is, okay? And that's true like as consumers and for markets, which a market is just an aggregate of consumers. Okay, so hopefully that's not too surprising that, yeah, that's the way people behave. And it's because of that that the demand curve will have this characteristic shape of falling as you go to the right. Okay, it comes from the law of demand. Now, notice I underlined in red there, all else being equal. There are lots of other things that affect how much of any item people will buy on a marketplace, okay? And how much they'll buy at a certain price. What we're saying is if you hold everything else constant that might influence this situation, as the price falls, the quantity demanded will rise. Okay, that's what all else being equal means. And it's a very important part of this statement, okay? Now, in reality, it'd be very hard to have a market and hold every factor that might influence this constant and then start tinkering with the price and see what people do. But this is meant to be like a law of nature of sorts, that this is just how we expect and how it makes sense for things to be. Okay, all right, now that's the demand curve. That's the nature of the demand curve, the interpretation of the numbers, the law of demand influencing the shape as it falls down and to the right. Okay, now let's talk about this next curve I have, which I forgot to label that one, but this one is the supply curve. All right, so in the market, there are consumers that are buying products, and then there are producers that are supplying products. Okay, so here's a supply curve, and you can interpret the numbers in almost the same way as the demand curve, but it applies to producers, not consumers. It applies to the sellers and not the buyers. But if this point right here has a quantity of 80 and a price of 5, if those are the numbers, it says at a price of $5, producers are willing to supply 80 units of the product. Okay. And notice the shape of the curve is a little bit different. Now, again, whether the supply curve is actually a curve or a line, whether it's steep or whether it's relatively flat, is besides the point. The supply curve will have this up and to the right shape. Okay. And the reason for that is because of the law of supply. It again starts with this very important phrase, all else being equal. As the price rises, the quantity supplied will also rise. And I hope that you'd think that that's just, again, a very reasonable expectation for behavior. All right. That yes, if I'm selling something, then the more it's going for, the more that I'm willing to supply. There's all these factors of production and raw materials that I have to spend money on to produce the item. And, if the price rises, it's in my interest to sell or try to sell more of it. Okay. So hopefully that's not too mysterious, as you are acquainted with human behavior in general and your own behavior in particular. All right. But anyway, so that's demand and supply. Those are the laws and the way we think about the graphs and so on for how producers and consumers behave in the marketplace. Okay? All right. Now, as a little disclaimer, going forward, this is a little bit of a theoretical construct. Where I'm getting these numbers, I didn't explain. I'm just asking you to accept that they're reasonable. Okay. But we might expect something like this is happening, even if we can't access the exact numbers. In reality, in a marketplace, it's very complicated. It might be hard to determine the exact prices and quantities that go together. But again, something like this is happening. Okay. Now, let's talk about this thing called the equilibrium price. Okay. And my setup for that is that I want to explore the question of how do buying decisions of consumers interact, and selling. Oh, whoops. That is a terrible type. How do buying decisions of consumers? I'm sorry. Let's do it like this. Okay, that's better. So how do buying decisions of consumers and selling decisions of producers interact? Because here I have the supply and demand curves in isolation, where I give you those so that you can interpret the points, the individual points on the curves, and understand something about the shape that we'd expect them to have. Okay, but in the market, that the consumers and producers behaviors interact with each other. Okay, so let's say that I have the supply and demand curves drawn together on one single graph. Now again, on that graph, the horizontal axis is the quantity that's bought and sold, and the vertical axis is the price. Okay, and my numbers, I have made them up. Okay, this is not based on any real product or anything like that. But I'm not worried about that because I'm just trying to get a certain concept across to you, okay? So look, they're right here. Supply curve here, going, as we said, up and to the right. Demand curve here, going, as we said, down and to the right. Now, let's say that the price happens to be $4, okay? Then what I'm seeing here is that at $4, consumers are willing to buy 25 units, okay? But producers are willing to provide 60 units. So why is that bigger? Well, they have a different incentive, okay, right? But anyway, so there we have it. We have a difference there in, for one singular price, how much consumers are willing to buy and how much producers are willing to supply. And what that would be is a surplus, okay? Why is that a surplus? Because suppliers are willing to supply and put on the market more than consumers are actually willing to buy, okay? So that's by definition what a surplus is. There is going to be a 35 unit surplus at this price. That's what the effect of that price would be, okay? So, all right, okay, yeah, it's at a price of $4. Producers are willing to supply 60 units, but consumers are only willing to buy 25 units, okay? So the surplus is there, and then what do surpluses do? If there's unsold items on the marketplace, unsold inventory, it tends to push the price down. So look at it like this. At this price here, if and since the supply is greater than the demand, then the price feels this push down, okay? It feels the push down because of the surplus. All right, now again, I'm telling you that just so the concept sinks in, that you see that, oh yeah, it's possible then for there to be a price that could produce a surplus. And then if that happened, it would push the price down. Okay, now let's look even closer at that. You see that there's this point where the supply and demand curves could meet, okay? And let's call that the equilibrium price. I'll tell you why in a second. If you had a price more than that, that's like what we just talked about. There will be a surplus and the price will have this tendency to be pushed down, okay? So it's like in that direction. But over here, this one I didn't talk about, but we can explore the graphs in the same way. At this price, demand exceeds supply, okay? And so there's a shortage. What happens on the market when there's a shortage? That will push the price up, okay? So if something's really rare and people want it, almost just by bidding, it pushes the price up, okay? But nonetheless, all right, there will be a shortage and it will push the price up. So what does it look like happens if there was a price on the market that either produced a shortage or a surplus? It wants to push them down into the middle, which is the equilibrium. Now notice this point where the supply and the demand curves intersect each other is the one and only point on my graph that doesn't have a surplus or shortage associated with it, and in turn is not going to have some price tending to push away from itself either down or up. Okay, now that's the equilibrium. With the word equilibrium, think balance, right? So if we're standing over here, we want to fall down. If we're standing over here, we want to fall up. But if we're standing at the intersection, then there isn't the surplus or the shortage, and then at least no factors such as that to push the price to some other number, okay? So that's what the equilibrium price is, okay? In concept, you can think about it in terms of balance, in terms of the graphs. If you want to think of it that way, it's just the intersection of the supply and demand curves. All right, now let's build this up even bigger. Let's go to part 3 and talk about what the consumer surplus is. Now at this point, I want to have another disclaimer. There's such a thing as the producer surplus, but everything I say about the consumer surplus, you just modify a little bit and you can understand the producer surplus. It's not really a totally different concept. So if you understand the consumer surplus, I'll leave it to you to read and think a little bit on your own about the producer surplus based on what I've told you in this video. Okay, so here goes. Consumer surplus. Now, suppose that we have our market and it's at balance at the equilibrium price. So let's say like right here, this point is the equilibrium price. Okay, all right. So the price as it exists on the market is $5, the equilibrium price. Okay, now here's a consequence of that beyond what I've talked about so far. There is this point on the demand curve, okay? And what does that mean? This point even existing. And I'm just taking this point at random just to illustrate that there are points over here and here's what happens. But this point in particular means that some consumers, at least some of them, are willing to pay $2 more than they actually have to. You know, this point being there are consumers that are willing to pay $7 for whatever this item is, okay? But they only have to pay $5. So it's like there's some benefit built into the market. The market tends to push itself towards this equilibrium price, okay? So that's what people pay for the item, okay? And then so some people are better off for it, okay? It's like they have this $2 benefit. And that's unseen, right? It doesn't change hands when people buy anything. If somebody goes to buy this item for $5, this $2 benefit is like nowhere to be found, but it still exists. It's still real, okay? So economists like to quantify things like that, all right? There's the things you see and the things you don't. It's, you know, like unintended consequences. You've probably heard of those, okay? Things that we could imagine happening whenever we make some action, okay? But they actually did happen. So here there's this where it's like I can't actually see it. I can't hold it, but it's there. That's called the consumer surplus. This difference right here. The fact that people actually get to pay less than they actually would, all right? Okay, all right, now, so that's all the consumer surplus actually is this difference. Now, you might say, well, that's just one point, though. And that's true. I just picked this one point. There are lots of other points on there representing the fact that there are other people on the market that were willing to pay maybe even more than $7, maybe less, but there's lots of people willing to pay more, or sorry, yeah, willing to pay more than the $5 market price. So it's like we would have to account for all that, okay? So look at this picture right here. And this is what explains what I told you in the video yesterday, that the consumer surplus is the area under the demand curve, okay, but above this horizontal line that is the equilibrium price, okay? That mathematically, as far as how we measure it, that's what it is. So this slide tells us that, right? So think almost going from this picture and that little vertical line right there that represents the difference in what some people were willing to pay versus the smaller number what they have to pay. You just extrapolate that to this entire area, all right? So that's like the total number for what consumer surplus is, okay? It'll be all of this area. This area, as I said, under the demand curve, but above this horizontal line that represents the equilibrium price, you know, over to where that equilibrium price is, okay? If we went past that, then, you know, that doesn't reflect what I was just telling you. So it's just like right up to here, if this right here is the equilibrium point or the equilibrium price, okay? All right, now I thought it would be good to follow this up with one quick example and explain something that's beyond what I showed you in the video yesterday. In the video yesterday, I worked out an integral here, a definite integral to calculate the consumer surplus, okay, which was just an illustration of this formula. But let me do something kind of like that, but I want to tell you one additional fact about it. Okay, so let's say here's what we have. We have this, which is our supply curve, and this is our demand curve. Okay, I want to calculate the equilibrium price and the consumer surplus. All right, so here goes. Let's do like this. Equilibrium price. So think back to earlier part of the video. That's the point of the intersection of the supply and demand curves. So I can take their equations, whatever they are, I can set them equal to each other, and I can solve it. When I solve it, I got Q was 30, and then I substituted Q being 30. I could put it in either supply or demand because we're looking for the point of intersection that's on both of them, either of them. So I take Q being 30, I happen to put it in the supply, and I got P is 10. Okay, so the equilibrium price is $10. All right, so let's do this, make my answers official. Okay, so that's the equilibrium price. If we happen to want the equilibrium point, then that has Q to be 30 and P to be 10. Okay, so just depending on what you're giving for your answer, that's the difference. Now, what about the consumer surplus? So think back to what I said. The consumer surplus, now here I've drawn the graph. I've actually plotted the supply and demand curves. It's not to scale or anything, but it looks a lot like this. These numbers are accurate. The demand curve has a intercept on the vertical axis at 24. Okay. The equilibrium point is 30 for quantity, 10 for price. You see there, that's where supply and demand curves intersect. And the consumer surplus would be the physical area of this. Okay, so why is it the area? Well, because I'm trying to extrapolate from this $2 vertical distance being, you know, for one individual point what the consumer surplus is to this total area. Okay, so like it says there, the physical area, the size of this region on the graph is the consumer surplus. However you want to measure that. So yes, this is what I want to measure. If I could measure the physical size of this triangle, okay, then that will be the consumer surplus. Now, think about what I just said. It is a triangle. Since these graphs are lines, then this region under the demand curve, but above this horizontal line that is the equilibrium price at 10, okay? That's a line and a line coming together. It's a triangle. The area of a triangle is 1/2 base times height. So I looked on my graph and I tried to figure out the dimensions of this triangle. If this point is 24, but this horizontal line is 10, then that makes the height 14. And if this triangle stretches from right here on the vertical axis over to 30, then the base is 30. So, all right, the size of the triangle is 1/2 30 times 14, which is 210. Okay, so my consumer surplus is $210. Okay, it will have units of currency for whatever your measurements are. Let's say dollars. Now, that's one way to do it, since the consumer surplus is the physical size of this region of the graph. I can calculate it that way. Now, I did, in my video yesterday, tell you that this integral will measure the consumer surplus. And that's because this integral will, in general, even if this isn't a line and that's not a triangle, it will measure the area that you see there under the demand curve, but above the equilibrium price. It will do it. It will tell you. Now, I often draw the supply and demand curves as lines, but they might not be lines. They might be curves. They might have some weird shape to it. But this integral will tell you the area. So, since I know it's a triangle, I could calculate the consumer surplus that way, by the area of that triangular region. Or this definite integral, because this definite integral measures the same thing. It also measures the area as you see here. Now, if you work out this integral, this definite integral, you'll get 210, just like over here. We wouldn't get different answers. These are just two methods to evaluate the same thing, okay? Now, so that's something that I did not tell you in the video yesterday. the fact that there may be some other way to measure the area that you see on the graph. Now, when might you be able to do it like this? If that region is a shape that you know. So if you look over here at the graph and you see that you want to measure the area of something and it's a triangle, then you know a formula to do that. 1/2 base times height. If it was a rectangle, same thing. There's a formula to measure the area of that. If it's any shape that you know the area of, then you could measure the consumer surplus this way. Otherwise, we could use the integral. Okay? All right, now, however you want to do it, that's up to you. I just wanted to show you that there's an alternative to the integral and that either way, we're measuring the same thing.